I know I'm popular, but this popular? All right, just to prove that people actually want to hear me rant, I'm going to take a selfie with you all. Because nobody believes me when people actually want to hear angry people talking on the internet. There we go. Right, that'll end up on Twitter in 20 minutes. Oh, preparation. No, too much like harder work. Right, so do we give it any more moments for them to squeeze in? Go through the other door. It'll be easier, dude. Okay, yeah, front row seat. I'm cool with that. Right, so NoSQL is a lie. Who here actually wants to know what this is about? Okay, so there's some people who are actually interested. Yes. Right, I have to work at a big company, so I asked for a legal disclaimer to make it easier for me to deal with this stuff. This means I can lie and stuff, and they hold me responsible, not them. So I am Mike Elsmore. I'm a developer advocate at IBM. I work specifically in this little bit of IBM called IBM Cloud Data Services, or Analytics Platform Service. Hands up if anyone's heard of this thing. You work at IBM? Okay. Right. So I work with these things. So these are all databases or analytics tools or data packages. Please note, most of these are open source technology. It's a miracle. IBM has open source technology which you can use. The only exception being this thing here, where is the other one? And that thing, which are proprietary pieces of stuff which I'm not going to talk about. But the rest of it's all open source. You probably recognize some of the names. So Elasticsearch, Mongo, Redis, Postgres. It's a weird little database. Some people use it. Yeah, and Cloudant, which is CouchDB. Any CouchDB fans here? Yes! We do exist in the world. CouchDB is friggin' awesome. Right. So most of my day, like the rest of you, is usually something like this for the morning. Sometime around lunch, I'll do this, trying to work out what the morning was happening without coffee. And by the end of the day, my day looks a bit like this. And for this week, it's looking a bit like this because 3 days, Jesus Christ. But I'm just a bit of a proof on this stuff. I am not an expert about databases. I'm not a sysadmin for databases. I'm not an ops person for databases. I'm just a hacker who happens to have played with a lot of databases and built some random things that do stuff on the internet. So this is just completely opinion. It's not fact. So I, at this point, will invoke the open heckle policy. If you want to call me out for saying something that's obviously wrong, put your hand up so I know that I'm saying something that's a bit BS, okay? Also, I'm British and I talk really quickly, so if I'm speaking too fast, just somebody shout at me to slow down. Yeah, okay, fine. Right, so I have an inflammatory title, NoSQL is a lie. The reason it's inflammatory is because it's a goddamn rant. This thing actually makes me quite angry, and it'll become clear to you why. So this term NoSQL, who knows what this is? Yeah, you're wrong. Most people... NoSQL is actually the name given to a database called the Strozzi NoSQL system. This was a relational system without an SQL interpretive header on the top. So when you think NoSQL, it's Mongo, it's everything else. No, you're wrong. It was then horribly reused by somebody from the journalist world in the mid-2000s who went and used it as the definition for, I need my both hands for this, Web 2.0 database technologies. Seriously. So NoSQL is usually considered by most people to be this horrible try-catch statement where it's, if it's SQL, it's SQL. If it's not, it's NoSQL. That's horrible because of this whole backronym problem with, it was a database once upon a time, and then it was this horrible, catch-all for things. It's wrong. Is there also this horrible thing where you can now have SQL on NoSQL? Who's been playing with Cassandra or Couchbase or even things that have a Sparkle interface? Just hands up, who's seen these things, and do they look like SQL? Does it read with a select statement, etc.? It's freaking SQL without the joins. It's SQL. Right, and then there's this horrible other one where they say it's schemaless. Right, now, that's a load of bull. As developers, we implement schemas so we know what data we have. We don't just drop random stuff in there. We go, we're going to put this stuff in the database and pull it out later. by definition, that's a schema. It's just not in the database, it's in the code. It's a schema. There's also this horrible thing where there are no NoSQL experts because there are too many types. So if you say you're a NoSQL expert, please follow the instructions. You could be an expert in a specific thing. You can be an expert in any of these specific NoSQL databases. There are over 80 Apache database projects, and this isn't counting all the ones that are like privately owned or proprietary software. So make that 500 databases. If you're an expert in every last one of them, I will get on my knees and kiss your feet right here. No, okay, my mouth is safe. So yeah, so that's the end of my rant. It's a little bit, yeah, let's not go there. So I need to calm down, it's time to be cool, and time to explain what NoSQL actually is. So to do this, we need a little bit of science. If you can't tell, I like GIFs. So, right, so we've got CAP Theorem. Who remembers this thing? It's also known as Bowker's Law. It's the rule for those who don't, it's the rules that explain how distributed systems work, so how you store, process information across multiple machines. This is changing nowadays because of some recent inventions, but it still holds true for quite a lot of technologies and distributed systems. So what CAP Theorem stands for is consistency, availability, and partition tolerance. So let's just quickly go through these. So we've got consistency. What that usually means is what you put in, you get out. So you put 1 in, you get 2 out. You put 2 in, you get 2 out. You put 3 in, you put 3 out. I said 1 and 2, didn't I? Yeah. Damn it, I realized afterwards. So you put 1 in, you get 1 out. You put 2 in, you get 2 out. You put 3 in, you get 3 out. I should have practiced this more, sorry. And then there's available. This is kind of self-explanatory, isn't it? It's especially when we're talking about databases. You want to be able to ask your database a question. So it's your database is there. If your database isn't there, I'm pretty sure most people's apps are just going to go, done. So these, and then there's this other part, partition tolerance. I like to think of it as where the system knows where the damn data is. So when it looks at a distributed network of things, it goes, that box. That box. Oh crap, I don't know where that box is. Well, that's a problem. So what it actually means is it's partition tolerant actually means it's tolerant to failure. So certain nodes can drop from the system, and the system knows how to work around this. So in case of most distributed systems, it uses sharded methodology, so algorithmically distributing across multiple machines. So usually it knows where things is. In a distributed system, you kind of need to know where things are. So no matter what you do, you kind of need the P. So in this diagram, as all good presentations should have, we have CA, so you could be consistent and available, which you can't really have because if you're in a distributed system, you kind of need the P bit. So you could be AP or CP. There's this weird, horrible mucus color in the middle. I call it the snot zone that doesn't exist. So technically in CAP systems, you can't be CAP, so it's the snot zone. That's my official coined term for it. So it's a pick-to principle. You can usually also call this the uncertainty principle because actually, I'm not going to try and explain that because I always fall over. Anyone want to give a decent description of the uncertainty principle? Oh, I'm meant to be talking to you, aren't I? Right. Okay, let's move on. So why is this important? Right, so historically, we've all dealt with consistent and available systems because we ignored the distributed part. Who has been developing for more than, say, 5-6 years? Right, so that means you're all used to having MySQL, Oracle, Postgres, DB2, you name it, database insert here. You used to just stick it on a giant box, and then when the box got full, you put more drives in it and stuck it on an even bigger box. And then when that got full, you stuck it in an even bigger box. Eventually, you found out about this thing called master-slave, which essentially meant you had one massive box with several smaller boxes in front of it. So essentially, you just kept getting bigger and bigger and bigger. And then it got ridiculously expensive, and somebody in management was going, money? But in the last 10 years, distributed systems have become easier. People like Amazon and SoftLayer and all these other companies with their cheap commodity hardware have made life easier. So distributed systems means we can we can have all these boxes, but it means we also need to know where all the information is on all of them. So it has to be partition tolerant and insert something. I have counted out these spaces. It counts for consistent and available. So this is exactly what is necessary. So you have to have a partition tolerant system and go with consistent or available. So that's the main driver behind this with AP and CP. So all the database technologies went one way or the other. Available being it's always there, but you'll have an eventually consistent system, which means eventually the system will know everything everywhere. Or it'll be consistent, where it'll have write locking, so that the system will be the same everywhere, but it'll lock up and stay locked for longer. There is a new classification of database called NewSQL. Yes, it's an original name. We've gone from NoSQL to NewSQL. But it's to allow this more transactional database system. It was actually brought about by the Google Spanner project. Anyone heard of this thing? Right. Do you know how they actually solved that problem for having transactionally safe systems in distributed system? Yeah, they had an atomic clock to every machine. They had a computer, which was about $2,000. They then added a $5,000 atomic clock to make it work. I don't think that works at scale. So some of the ridiculously smart people from that project have then gone off and created this thing called CockroachDB. It's a horrible name, but I'm pretty sure it just means you can't kill the bastard. So they're trying to implement the same sort of technology as an atomic clock in software on multiple machines. I'm not going to lie, I have no freaking clue how they're doing this. I look at them and go, it's Gandalf, wizardry. Right, so for the rest of the talk, we now know where there's a design decision. Bing! The design decision to do all this stuff. So let's move on. We're going to stick with some specific types of database. So,
this with the database, like Teradata, Exadata, so what category they are?
Usually they're classified as big data, which in my world actually is it's just a freaking database too big for my laptop. It's just for large batch processing and large manipulation of data, usually in a worker-based processing methodology, otherwise called as data warehousing. May I move on? Cool, right. So the first one up, key value stores, document databases, columns, and graphs. There are other types of databases like object, columnar, tuple, triple, quad store, multi-model, and a few others that I've forgotten the names of, so I just put ETC so I can skip them. But the problem with these are they kind of fit multiple scenarios at once, so it's really hard for me to give you a use case for technology when it's use case for Swiss Army knife of all the things. So we'll glaze over those in a polite manner. So skipping multi-model, who here has internet on their phone? Excellent. Right, there's a URL there. I'm going to leave it up there for a few moments for you to go to, because this is where the talk gets a little bit interactive. And I'm sorry, there's too many of you for me to go, answer, answer, answer. So we'll build a game for you to all play with. I love watching this bit in a slide, because you just see people's head going bobbing up and down. It's like watching penguins feeding. That's like so 1990.
And this is more modern.
Oh, you're a developer. You should be able to use your thumbs. You could always use your nose. That works. All right. I'm going with it. When I stop seeing nods, I'm going to move on. Still a few nods. Still a few penguins feeding. Okay, hands up if somebody has got a weird little white page app.
Yeah, I got an opt-in gap.
Yeah, okay. That's enough people to make it work. Right, so first up, key value data stores. You know, there are these wonderful things. Can anybody actually name any of them? Yes, Pokemon slides. Quite proud of that. So, can we name any of them? So that first app, just start putting the name out, and hopefully I should see results of names from you guys, rather than me having to just pick you out the crowd. So, anybody giving any names? I smell a problem with my code. I shouldn't have built this app yesterday. Okay then, well, we'll skip this bit, and I'm recording this anyway because I'm using it as a survey for what technologies do people actually freaking know. So, key value stores, let's just say there's a lot of them. That list actually carries on off the page. So these things are... Can anybody see any of these? Can anybody name any of these? Any of them look recognizable? Let's skip Redis and Memcache, because if you haven't heard of that, you've been in a cave for 10 years. People are going to kind of recognize this, kind of recognize that. Yeah, either that or I can't read it, what you're talking about. The people at the back are going, ah, what? So, right. So what are key value stores? These are really simple, usually highly available systems. They are, you put a key... Nice. So they're key values. You treat them like an array, a dictionary, a hash. You've got a key, you've got a value, you put the data in, you look at the key, you get the value. They're pretty self-explanatory, right? So they have some really cool use cases. The most popular one being Redis, I would hands down agree, is the most popular key value store on the planet, possibly the universe, depending on your theories on alien life forms. So you can use them for storing sessions in distributed systems. You can use them for building dumbass queues. You can even do geospatial lookups in the most recent versions of Redis. You can also use them for storing partials. You can, for just speeding up things which you'd usually go to a database and go, please don't break, please don't break. I just want that one number, please don't break. So for caching, all sorts of little odd jobs, and they're just really quick. Because they're only primarily used for looking up on one giant fat index, is here, done. Everybody cool with that? Or am I talking gibberish? I'm talking gibberish. Oh, great. You'll just have to review the talk afterwards over and over again until it makes sense. So right, next up, document databases. Has anybody heard of these things? We have a few people who've heard of these things. They're actually a subfamily of key value stores originally, but what they did was they then extrapolated extra querying ability on the metadata contained within the objects themselves. So they still have ridiculously fast primary lookups, but then they have all sorts of different things on the side of them. So once again, can anybody name any of these? What's that database? So once again, if you want to put it into the app, I'm probably going to go with it's not working, so feel free to name them because I really want to know what databases people actually know of, and it'll help me improve my talk so that when later I can go, yes, people do know this weirdly obscure Chinese database that's been used 3 times in the universe. But here we go. Here's some random databases. Right, so it's Cloudant, CouchDB as a service. Ta-da! Promotion. And then we have Mongo, Couchbase, Rethink. The top ones on there, can anybody name them? Well, not name them. Can anybody see ones they recognize? Mongo, yeah. Mongo is not the answer to all the things. I will. Right, so...
Why is Oracle NoSQL in key value and non-key?
Because it's technically a key value store. The indexing is extra. It's a plug-in system. It's not actually baked into the database. Moving on. So considering it's a subclass of key value stores, it relies on the document to have large amounts of metadata to actually work with. So you can do the same in a key value store, but then you have to build shit tons of indexes independently. This just automates the process. My favorite one, CouchDB, relies on its primary system of lookup being a MapReduce-based system. Anybody recognize using MapReduce? It's a total head case to work out first time around, but it's genius after that. Also, just as a CouchDB question, if I ever see anyone using a custom reducer, I'm going to kill you, because that's bad. But these things have been actively developed and improved upon. They've also brought in other projects. So CouchDB, earlier this year, released the Cluzo and Dreyfus plugins, which are going to get merged into 2.0, which is just being released in public. And that, what it allows is for loose scene indexes, so ad hoc querying on top of document databases. So in the same way that you can do friendlier Mongo queries, it now allows you to do that sort of ad hoc querying on CouchDB. Most of the other document databases have the same thing going on. So why would you use it? Because they're an operational data store. It's for when you don't want to have multiple tables doing random joins onto different things to give you some basic information. You just want to have user profile, item, thing, pull it out. That's why you use a document database. They're also, once again, traditionally built to be highly available. So they are usually, in a clustered environment, a eventually consistent system. Even Mongo in a cluster is eventually consistent because it just keeps all the memory, dumps the disk, distributes it across it, and there's a slight lag. And the moment there's a slight lag, that's an available system rather than a consistent system. So you do have to do some clever work usually to make sure your system works in that eventually consistent format versus working consistent, like you do with an SQL, the standard SQL service. Next up, well, actually, I just check. Was I talking gibberish again? Did that actually make sense? Yes, I have taught something. Either that or you already knew it, and I'm sorry. Next up, column databases. So, otherwise known as wide column databases. These are quite useful things. So, can anybody name one of them? Pardon? Big table, yeah, technically, yeah. I should really go to the name it slide, really. Once again, feel free to put the information in there because I really want to know stuff. So there's also these ones, which is Cassandra, Accumulo, HBase, Hypertable. These are really, really cool systems. I'm going to use Cassandra as my primary one because I freaking love Cassandra. The gossip protocol on there is like, squee, data nerd. So what is a column store? It does, under the hood, store stuff as tables, essentially. It's stored in rows and in columns. The difference between that and a relational system is you usually tell a relational system where there's no data, put null in, right? Column systems just kind of ignore it. It's like, that's sensible. Doesn't exist. Don't put it in the system. That's a great idea. So they are kind of relational. It's the reason why CQL works so well on top of Cassandra is because of this basic relational-like structure, even though it isn't relational in itself. It also means that they're quite elastic because you don't have a schema, because you don't have that, well, I said you do put a schema in there. Because you don't have a preset schema in the database, you can just extend the columns, and all it means is all the other rows that don't have that column, they don't bother adding it. It's like genius, scalable data systems. It also works, well, who here's heard of Chaos Monkey? What about just the Chaos Army, Simian Army? Okay, right. These things are a great tool. Tell your boss you're going to run it on production and see what happens. This thing just knocks out machines, data centers, the whole shebang and just sees what happens. Most people just, to put it politely, shit bricks when this thing's run. Netflix, on the other hand, run it in production and just go, you know what, we're still working. Win! That's when you go, okay, somebody's done their architecture really well. They take out half their Cassandra cluster and go, right, we're still serving Game of Thrones. Well, no, House of Cards. Game of Thrones is on HBO. So I've kind of given this one away. Why would you use it? Once again, it's an operational data store, but due to its model, it's a lot easier to move from your SQL service onto CQL. You don't get joins, so you still have to learn how to know SQL, but you do get this lovely ability to kind of map it in. It's also massively distributed, and it's designed for complete network failure, which is fantastic from a distributed systems engineering point of view. Right, once again, double checking. Talking gibberish? Making sense? Has anybody learnt anything? Hands up if anybody has learnt a single iota of information. Yes! Right, now for my favorite thing. This is graph databases. These are freaking insane. Anybody remember the graph theory from university? Yay, so I'm not going to talk gibberish to everybody, but these things are insane. I'm not going to lie, graph systems are really hard, and they usually don't work. So when they do work, it's like, yay! But it's, relational structures stored in a multi-related way, so you can do cyclical query really nicely. Let's do that. Name that database again. Popular databases. Neo4j. Anyone heard of that thing? TitanDB? Giraffe? Okay, so, right. I would go through the rest, but I actually, from Sparksy, I actually have no idea what they are. I've not even tried installing them, so I'm going to politely ignore them. What are graph databases? These things store things as discrete pieces of information and their relationships between them. So you have nodes or vertices and their edges. So, you have nodes full of people. So the best example for this would be Kevin Bacon. 6 degrees of Kevin Bacon. Interconnectivity of people using the ERDOS space principle. So you have each actor in the universe is a node, and each film they've starred in is a edge. You then connect all these edges to all these actors, and you go, oh my god, I'm 12 degrees separated from Kevin Bacon because I was an extra in Star Wars once. But these discrete pieces of information, you can do these traversals which allow you to be cyclical, look back upon yourself. Rather than having to know what the exact query is, you can tell the system to kind of guess and go, I've reached this node, this is the decision tree I now make, move on to the next, versus this is the exact join query, now let's kill Postgres. So it does rely heavily on its metadata, and it does rely on first-class citizens on edges and nodes. So why the hell would you use it? 6 degrees is Kevin Bacon. Social networking. Giraffe was developed by Facebook back in the day as its original model for its social graph. I don't know what the hell they use now, but they've gone nuts and built something else on top of it. So, you know, best things, those. There's also recommendation engines, fraud detection, all those weird edge casey things that as developers we go, that's kind of boring, we'll leave that to somebody else to deal with, or download a free project. But you've got plenty of other things you can do there. You can also offload stupidly big queries that would normally kill your operational database onto there because, you know, it's not in your database, it's somewhere else. Right, so once again, gibberish. Who thinks databases are cool? Oh, wow, data nerds are with me. Yeah. All right, so I'm a little bit exhausted after that, but I have to give you some proof of why I believe all this. So for the last 3 months, I've been working on this thing called Ambrosia. We've built nutrition as a service with these 3 nerds. We even have matching hoodies. And we went around and we built this thing on Graph originally, just straight onto a graph, taking relational information, putting it in data warehouse, modeling it, and throwing it in there. I should really put the model in there. So we took all this horrible information, we did some ETL on it, threw it in a graph so we could do some complex querying and look through the information, and kind of realized, right, graphs are great. Problem is they're not really performant, so we need to put an API layer in front to make it easier, and on top of that we need to put a caching layer to separate things out. We need to make things indexable really quickly, and we need to be able to cache partials so that we can easily serve them. So we ended up throwing Elastic on there so you can do, you know, partial querying upon groups of information and getting lists. We then threw every individual object into Redis so that when you were looking up on an individual ID, instead of looking at the database and go, give me this one piece of information, 2 minutes later, we go, here's a piece of information, 20 seconds later at the top end, you can have something date back. So, you know, you pick the tool for the job. So you pick Redis for ridiculously fast single point lookups, you pick Elastic or any other form of list-based indexing system to improve your querying based on and/or queries. You then throw in a graph to make these stupidly complex, windy, twisty, timey-wimey, wibbly-wobbly time stuff. You then have different kinds of operational store, Cassandra or CouchDB to store user information alongside your API. Not everything has to be inside of an SQL database or on Mongo. Yes, nothing, you can pick the right tool for the right job. So there is some reason to party after all this. So, what have we learned? NoSQL is a lie. Hands up who agrees with me. Nobody agrees with me, really? Okay, one person just tell me why I'm talking bullshit. The term is a lie. It's a catch-all statement or it's a misnomer. It's people who believe Mongo is everything, CouchDB is everything, Cassandra is everything. No, it's NoSQL is a term describing multiple technologies, and you pick the correct technology to do the right job. Breathe. Now do people believe me NoSQL is a lie? Oh, seriously? Right. Right. So we know why NoSQL evolved. We know that the history of it meant that it was born into this horrible way of living that works distributedly. Right? And we know there are many different databases for the job. You have key value, you have graphs, you have document, you have triple, multi-model, everything else in between that I'm not even going to think about. Okay? Please somebody agree with me. Otherwise 30 minutes of my life has been wasted. Okay, someone's agree with me, I'll take it. And then for, you know, once again, I'm going to reiterate this until I die. There are reasons to use other databases. You don't have to do everything in the same thing. Yes, you can, but sometimes you really shouldn't. So pick the right tool for the right job, people. Because if you don't, you get a hilarious, I'm going to have to talk slowly, you get a hilarious situation where you can pick the wrong tool, and that happens. And in production, or whilst you're developing something, you could eventually just be sat there waiting for it. I'm going to make Postgres bend to my will. But if you do it right, you get a lovely huzzah. So, that's me. That's my talk. And here is the inevitable drop mic. Thank you. Questions? Do we need mic? Yeah, we need mic.
Just a fun question. So how many databases have you actually tried?
As of last count on this Mac, before I had to nuke it after running a really bad Docker experiment, I tried 27.
Okay.
It's my job to play with them, so I just plug it in and go, can I use it? No, move on. I'm really sorry, the people right at the back, we're just going to have to like javelin the mic to you.
I'm looking at your GitHub and I'm interested. What are all the tools that you use to make the... I see Node.js, but how'd you make the presentation? I really love it.
That's the most random question I've ever had. It's a technology called Reveal.js. I just happen to have a custom Yeoman build that I then build my slides, and I hack shit together with CSS and JavaScript.
Awesome. Thank you.
Also, there's a little something I should probably own up to. I've embedded my face in every one of the slides, so you've been watching me twice today. I had much fun with that yesterday. And people are just noticing, there he is! It's great. Any more questions? Yep.
Next one, hi.
Hi!
Why CouchDB?
Why CouchDB? Because it's random as hell and does some stuff that a database never should.
What stuff?
For example, you can store actual files in there. You can actually serve HTML directly out of the database, JavaScript, anything else like that.
Encoded images and all kinds of
You don't even need to encode it. You can store it as the actual raw object. CouchDB, it's if you look at some of the older things, it's CouchDB hosting the service itself. It used to be the dashboard was served directly from the database, not as a separate application, which is insane. Also, it does things like replication, so the replication technology allows you to sync it between multiple machines. And as I'm a web hacker, there's a library called PouchDB, which means I get to do database stuff in the browser and not give a crap about actually building a database. I kind of do it here, and it ends up in a database elsewhere. It's like, much easier to do. Done. All in JavaScript.
Thank you.
Hi.
Hi!
What graph database do you prefer and why?
Pardon?
Graph database. What do you prefer and why?
I currently prefer the Tinkerpop 3 with TitanDB stack. That's what we currently use at work. I love it because of the complexity and random stuff you can do with Gremlin. It's a language, which is a DSL based on Groovy. So you've got this wonderful dot notation language. So if you use JavaScript or Java or anything, you can easily interpret. And then because it's a DSL on top of Groovy, you can just stick in random bits of Groovy and make it do some random stuff. Like you can actually just make it compute on the fly. You don't need to use the sugar that most languages give you. You can write the language itself for you to do the job at execution, which is insane.
Thank you. One more question. Do you have any opinion on Neo4j?
Neo4j. It's actually really good. It's quite expensive for the enterprise version. My only problem is I really hate its open source stuff, which is it owns the open source. So you actually have to wait for one of them to go, yes, we want to sell your PR before they'll put it back in, which really annoys me. If it was open source under a proper Apache license, then it'd be really cool.
Thank you.
Any more for any more? I am here all night, people. And should have just throw it.
What do you, for the new databases that are coming out, what's the most interesting ones? What are the kind of new technologies?
CockroachDB. Just because it's random as freaking hell and I want to play with it, but it's still in alpha, so it's really, really buggy. But when it gets into a beta production state, it's like, oh my god, nerdisms. Does it answer your question?
What's the worst thing you've ever made a database do?
I once tried making MySQL do graph queries using stored procedures. It was horrible, and I regret it to this day, but I was young and naive. It was about 2 years ago. Any more for any more? Oh, shit.
Sorry. So since CouchDB and Couchbase has similar roots.
Yep.
So versus?
They're different use cases. So Couchbase is primarily in memory. So when you want to do lightning quick lookups of information you've recently stored, it's like stupidly good. So for online gaming, it's fantastic because it's do. The problem is it relies on everything being in memory. So if the machine shuts down, all your database goes poof because it's not on disk. Whereas CouchDB and Cloudant, they're designed for write to disk always. So if you're writing stuff that you don't need really quick, you just want it to be stored. So say, I don't know, you've just got a note taking application on your phone. You want it to be stored so you can go look at your computer and it'll be there later. It's like, that's really good because it's always on disk. If it fails, it tells you it's failed rather than Couchbase where it'll stick it in there and it may accidentally fail because it has a buffer overload and data's gone. It depends entirely on your use case. Sometimes Couchbase is much better. Uh-oh.
Okay. Just batch updates, a bunch of batch updates.
Pardon?
A bunch of batch updates.
I personally go with CouchDB because it's free and easy to use.
Okay.
And the 2.0 version means it has a Dynamo-based replication model underneath, so you can actually make it do proper distribution now, rather than that hokey will just let it replicate and cost us lots of money. Any more? This dude at the front.
So question, why not Postgre? Like, if you need key value, you can use a bloody table with bloody 2 columns with 1 key and 1 value. If you want collection in Mongo, you can use table with 2 columns, 1 is JSON.
Yep.
So why not Postgre for these things?
Right. In the case of using an SQL service in replacement for that, why would you do that? Because it's for the common use cases for key values are caching and partial storage and fast lookups. Right. So that means you're doing ridiculous amounts of write on your operational system. So if you're doing that in a system that's scaling to millions of users, you're just creating loads of empty reads and locking tables for when writes need to go in of important information. That's why. As for the using collections in Mongo, yeah, you can. But it's not designed to do that. It's like people make Mongo do graph queries. It's got graph stuff in there, but you'd never throw that at a production cluster because it wasn't designed to do that to begin with. It's just like, you know the double claw problem? Yeah, it's that. Boom. Right, are we cool or can we all go for a beer? Thank you.